Welcome to Chapter 2, Section 4. We will continue on with our problem solving, but in Section 4, all of these problems will have something to do with a percentage, or a ratio, or proportion. Here we have the most basic form of the percent equation, where you have an amount equal to a percent times some base. First thing to note, make sure that when you're doing these calculations, you always have your percentage in decimal form. A helpful tip is to take the words and values given to you in a problem and to organize them in this way. We'll have some amount equal to or is a percent of some base. That is, if you start with this format, you can fill in the amount, the percent, and the base. This will make sure that you know how to put them back into the equation, that you're putting the right value in for the base, the right value for the percent, and the right for the amount. Let's try some examples. For example 1, let's look at part A. Let's set up our blank statement. Clearly 25% is our percentage. Also, the number 44 comes after the word of, which is a big clue that 44 is the base number. Last, the question, or the what number we're looking for, is our amount. That's unknown. So now we have x is 25% of 44. Putting that into our equation, we have our amount x is equal to 0.25, which is 25% in decimal form, times the base of 44. If we do 0.25 times 44, we get 11. So we find out that 11 is 25% of 44. Let's skip to C, and we'll do the same process. In C, we have 39 is 60% of what number? Let's fill in our blanks. 60% is our percent, and the question of what number comes after the word of, so the value we're looking for must be the base. That leaves 39 for our amount. Now putting that into our equation, we have our amount, 39, is equal to our percent, 0.6, times the base. In this case, that's our unknown x. Dividing both sides by 0.6, we find that x is equal to 65. That is, 39 is 60% of 65. Let's look at example 2. Example 2 is similar to example 1, except for this time it's the percentage that is unknown. Let's look at B. What percent of 880 is 484? Let's fill in our blanks. We don't know the percent, so that's our unknown value. We'll call it x. The number 880 comes after the word of, so that's our clue that 880 is the base, leaving 484 for our amount. Putting that into our equation of amount equal to percent times base, we have 484 as our amount equal to our unknown percentage times our base 880. Dividing both sides by 880, we find that x is equal to 0.55. In other words, x is 55%. 55% of 880 is 484. 484 is 55% of 880. Let's jog over to example 3. In example 3, we still have percentage problems, but now they are word problems. Let's take a look at A. Of the 500 children who attend an elementary school, 28% buy their lunch at school. How many children buy their lunch at school? Let's fill in our blanks. Our big clue is that the number 500 comes after the word of. So 500 is our base. Our percentage is 28%, and we're asking the question of how many. Switching this from words to equation, we have x is equal to 0.28 times 500. 0.28 times 500 is 140, so x equals 140. That is, 140 children buy their lunch at school. 28% of 500 is 140. I'll leave part B for you and head on over to percent increase. The percent increase is simply a measure of how much a quantity has increased from its original value. The equation that we use when we're solving problems involving percent increase is this. Amount of increase is equal to the percent of increase times the original value. Let's take a look at example 4a. At its initial offering, a stock was valued at $25 per share. That's our original value. If the current value is now $45 per share, find the percent increase in the value of the stock. Let's first talk about the amount of increase that's happened. The stock started out at $25 and it changed to $45 over time. So how much increase is that? That's an increase of $20. So our amount of increase is 20. The percent increase is unknown, so I'll write that as P. Lastly, we multiply by the original value, which was 25. We can now solve for the percent increase by dividing both sides of the equation by 25. 20 divided by 25 is 0.8. So our percent increase is 0.8. Written in percentage notation, that is the percent increase is 80%. I'll leave part B for you to try. Percent decrease is very similar to percent increase. We just change the wording. Percent decrease is a measure of how much a quantity has decreased from its original value. The equation is also the same, except we write amount of decrease is equal to our percent times the original value. Let's look at example 5. Lee bought a car brand new for $30,000 3 years ago, and now it's only worth $13,800. Find the percent decrease in the value of the car. Let's talk about how much this has decreased. We started out at $30,000 and the value changed or decreased to $13,800. How much decrease is that? It's a decrease of $16,200. So putting this into our equation, we have our amount of decrease, 16,200, is equal to percent, P, we don't know, times the original value of 30,000. Dividing both sides of this equation by 30,000, we can solve for our value of P. 16,200 divided by 30,000 is 0.54. That is, the percent decrease is 0.54 or 54%. Proportions and percentages are very closely related. They're actually just a different way to express the same types of relationships. A proportion is a statement of equality between two ratios. What we mean by that is two fractions. So say you have A divided by B equal to C divided by D. That would be a proportion. I have two ratios set equal to one another. The cross product or cross multiplying is a slick trick to simplifying proportions. If we have a proportion such as the one I just wrote down, We could solve it by first multiplying both sides by b and then multiplying both sides by d. What that's equivalent to is doing a times d and b times c, or a times d equals b times c. And you can see the way that I drew it, that's why we call it the cross product or the process of cross multiplying. Let's use this in example 6. I'll do part A. To solve this, I'll start by clearing the denominators with cross multiplying. I will do 3 times 187 and 17 times n. That is 3 times 187 equals 17n. 3 times 187 is 561. Dividing both sides by 17, we can solve for n. 561 divided by 17 is 33. So now we know that n is equal to 33. Let's take a look at example 7. Example 7, we have two problems here that are word problems dealing with proportions. The trick is being able to set up the correct proportion. Let's read part A. Studies show that 4 out of 5 dentists recommend sugarless gum for their patients who chew gum. In a group of 85 dentists, according to these studies, how many would recommend sugarless gum to their patients? Let's set up a proportion. In our first sentence, we're told that 4 out of 5 dentists recommend sugarless gum. The question is, how many out of 85 then would recommend sugarless gum? If 4 out of 5 dentists recommend it, how many would that be out of 85? Just by writing that down, we've really already created our proportion. Where I have the question mark, that's our unknown value. And these two ratios are equal to each other. Now we can cross multiply and solve for x. Cross multiplying, we have 4 times 85 equals 5 times x. 4 times 85 is 340. And we can finish solving for x by dividing both sides by 5. 340 divided by 5 is 68. So we find that x is equal to 68. That is, 68 out of 85 dentists recommend sugarless gum to their patients. And this completes this section.